Today we are going to look at a little deeper usage of our calculators. But before we do that, again, I want to do another SAT question. Again, keep in mind you want to listen to these things even though you may think you don't need them, so you can discuss strategies. It's just real quick. It talks about the formula above giving the monthly payment M, needed to pay off a loan P, dollars at R%, so we see a bunch of R's, with the annual interest over N months, so we also see a bunch of N's. It says which of the following gives P in terms of M, R, and N. Whenever they say they want you to give P in terms of everything else, it means it wants you to end off with the answer of P equals. And the easy way to see this is that you look at all the answers, and that's one of the strategies you can use whenever you take a SAT type of question, is look and see what the answers have, and the answers have a P equals on everything. And so if you remember I think it was chapter 2 that we learned how to solve for a variable. We know that we want to get P by itself, and there's a whole bunch of stuff over here that just makes it completely confusing. So in my experience, what I would do is, instead of dealing with all that, let's look at something simpler, and let's turn this to M equals, and let's turn this into a nice number like 7 over 5P. And if we were going to solve for P in that situation, I believe the first thing we would do is multiply by 5, which would give us 5M equals 7P, and then we would divide by 7, which would give us 5M over 7 equals P. And so what I recognize is that 7 over 5 simply got turned over into 5 over 7 multiplied by M. Using that pattern, it actually makes it pretty easy to answer, because what I would be looking for is this on the top and this on the bottom. So let's see. A is not it, because even though it has the M over there with the fraction here is the same, so it's not A. If you look at B, actually just look at C and D. C can't be it, because that's not even close to what it should be. D can't be it, because that's not even close to what it should be. It has to be B, but again, looking at the strategy we just used, this part should be on the bottom and this part should be on the top, and so your answer would be B. And so part of doing that, answering multiple choice questions, again, is using the information that is in front of you to determine what makes sense, what doesn't make sense, and sometimes narrow it down to something that is actually sitting right in front of you. But last week we learned how to graph scatter plots on paper and with a calculator. I hope you learned how to do it with paper, because if you did not, then the test this week is going to be kind of difficult, because it's not done on computers, and you have to be able to actually plot a scatter, or graph a scatter plot. We learned how to identify the correlation as positive or negative. Remember, positive correlation was going in a positive slope, negative correlation was going with a negative slope. If there was no pattern altogether, we found out it was no correlation. Today we're going to use this data in the scatter plot to create what we call a trend line, and an equation that can be used to determine values that are in or out of the range, that are out of the range of the window. A trend line itself is a line drawn in a scatter plot that splits the data in the scatter plot in half. This line represents what we would call the average of all the information, and it gives us an idea of where all the information should be. Remember, this is a scatter plot, and so you really don't know exactly where it's going to be, but if you can find a line that goes through the middle, then you can say, hey, if at this value the dot should be about here, although it can be a little bit higher, a little bit lower. Here it should be about there, although it can be a little bit higher, a little lower. It should be about here, although it could be a little bit higher or a little lower. Same thing there. And so trend lines here, if those were scatter plots, this would be a trend line. If that was a scatter plot with a negative correlation, this would be a trend line. The key thing about trend lines is that if you're asked to draw them, just do your best to identify a location that splits the information in half. In actuality, the calculator is going to give us an equation for the trend line, and that is the work we're going to focus on now. So for now, let's reset our calculators like we did, not yesterday, but I guess last week. And remember, to reset your calculator, you have the memory button here, which is second plus. That the reset pops up, so you could hit the button 7. You want all the RAM to be reset. That's all the memory and everything, so hit 1. And of course, I told you this is like a feature that keeps you from accidentally resetting it, then now you have to push 2, and you see the RAM is cleared and everything is cleared on our calculator. That way, anything that's been funny going on in our calculator is cleaned out. Now let's enter the information in the table like we learned last week, which is to simply hit the stat button. So we hit the stat button and we go to edit, and we put in 1998, 1999, 2000, 2001. I hope you're doing this with me, because when I gave you the quiz last week and I asked people to know how to do some of the features, there were a lot of you that had no idea, and it's because you probably don't have the habits of working along with me. So I hope that you're doing this, but if not, I hope you're ready for whatever might happen if you're not ready. 1339, 1406, 1421, 1470, 1415, 1472, and 1470. Alright, so I got all that entered into my calculator. Sorry I didn't do it on the screen. I didn't realize it was out of the screen, but anyway, all that's entered into my calculator. Real quick, I just want to kind of check everything. I've got 2007 going to 1470, which is right. I've got 2006 going to 1472, 2005 to 1415. Yes there, yes there. 2002 to 1406, 2001 to 1339, 1340, 1311, and 1289. Alright, so now that I know everything's there, it says let's look at the scatter plot. And again, this is where some of you got lost, because some of you just hit the graph button and the first thing you said to me was that you didn't know where it was at. The problem is, whenever you go to graph this, it's because your window is not big enough. So the first thing you had to do was make a window. And remember, your X minimum represented the lowest amount, and what I told you was that you could probably pick about 10 lower than that. So I would do 1988 for that, just because 1998 is the lowest number I use there. And I would go to 2017 for my X max. Don't touch the scale, because that's something that really is not important there. Your Y minimum means find the minimum Y number. So looks like 1289 is my lowest, so I'm going to do 1270. And my maximum Y looks to be about 1470, so I'll do 1480. And then when I go to graph it again, some of you even said, hey, my data's not showing up. And again, that's because you are not plotting the table. And what I told you is that this button says stat, and in blue right here is stat plot. And so you hit second and the button there because it's in blue, and you notice that your plot is off. And so what I told you is that you hit enter to select it, hit enter to turn it on, and then hit graph again, and there you go. So your scatter plot is right here. That is the general idea. And if you were going to sketch a trend line, it would go something like this. Of course, ours isn't going to be perfect, but if that was your graph, you would just have it go somewhere through the middle of the data like it does right there. As it says here, notice it is a positive correlation. We can actually use the calculator to sketch a trend line, and this is done by what we call calculating the linear regression of the data. In terms of taking notes, you might want to write those two words, because if you want to make a trend line, you have to find the calculate, and you have to use the form of linear regression. And let's do that now. So what we will do is go back to your stat table, and notice that the word calculate is there, and the linear regression is here in option 4. And so when you hit that button, this pops up and it's saying, do you want to find the linear regression of the data in your table? You hit enter again, and this pops up. It says notice the values of A and B are given. These represent the slope and y-intercept. The easiest way to remember that is that this is the slope-intercept form of a line, as we just learned. Y equals mx plus b, so you can recognize that A is in place of m and b is still your y-intercept. And so the slope of this line is identified by A, not m, and the y-intercept is identified by b. This gives an equation if we round to enter the slope-intercept formula. And I would go to 2 decimal places, so I would do y equals, since A is 21.44, 21.40, not 44, but 45, x minus 41557.29. And yes, that is a very messy equation, but it at least gives us a very, very close line for a trend line. And so when you go to do this, remember a skill we learned last chapter. If you want to graph a line, you hit the y equals button, and you simply type in the formula the way it is. So 21.45, x, remember, is that big X button here. It has x, t, theta, and n on it. And then minus 41557.29. And then you simply hit graph and you recognize that the line goes right through it. So again, the first thing we learned last week was how to do the scatter plot. Today what we learned is how to do the linear regression and then graph the line right through it, and that is pretty much what you are adding to it. That is the reason why I did not teach that all at once, because I needed you to at least have an idea on how to graph, on how to do your scatter plot before we did the trend line. Other than that, that is the general idea of what you need to be able to do today. But considering that this is a true source of information, the way that you use a trend line is to determine, well, if this is what the trend line is, and we have a table that tells us all the way up to, I think that table is up to 2007, that we should be able to figure out the number of tickets sold in 2016. And the way we do that is we use our formula of y equals 21.45x minus 41557.29, and you simply plug in the value of 2016 for x, because that was what the x represented was the day. And so we simply do 2145 times 2016 minus all that stuff there. Clear all that out and just type it into your calculator. 2145, I'll clear it, 21.45 times 2016 minus 41557.29 equals 1685.91. And so looking at this table combined with the answer of 2016 to this, it does make sense that it goes a little bit higher, because the numbers are going higher. You got 1200, 1300, 1400 in 2007, so it would be about 16 to 1700 by 2016, which does make sense. So just one more thing to cover for the lesson, and that is what we call the correlation coefficient. That is the letter R. Again, I hope you're writing this down. R tells us how much the numbers relate to each other. The values of R will range from -1 to +1, where a negative value shows that the relationship has a negative correlation. For example, on this graph, this is a positive correlation because it's going up, so your R should be positive. The second part of R is the fact that the closer it gets to the actual value of -1 or +1, the more tightly packed the plots will be. And so the easy way to consider this is to think about how some of you answer survey questions, to where they say something of, do you strongly disagree, do you disagree, no opinion, agree, or strongly agree. If you strongly agree or strongly disagree, you can imagine your dots are going to be strongly lined up, and disagreeing and going down. If you disagree, that means you really aren't agreeing all completely, but your lines are just kind of spread out a little bit, going in a downward direction. No opinion, of course, means that there's no direction whatsoever. If you agree but you're not really strong about it, again, your dots are going to go up, but they're going to go up in a more spread pattern, whereas strongly agree would be more like a straight line. Now, of course, it's not going to be that neat or that neat, but just trying to give you an idea of how the correlation coefficient works. Again, the ones are almost straight. Actually, if it was one, it would be straight. And the 0.5s are more spread out a little bit to give you an idea of what you're going to be looking at. The problem is, if you want to find the correlation coefficient, here's some more notes you need to write. You have to turn on the diagnostic function of our calculators. After that, it should be easy to do, but to do the diagnostic, you have to actually access your catalog. And so here's what we do. In your calculator, the catalog button is above 0, and it's blue, which means that we must hit second 0 to hit that button. And the catalog is a list of all kinds of things that your calculator can do. Two ways to get down to the diagnostic, which is what we're looking for. One of those is to scroll down, but you notice that this is in alphabetical order, and if you're looking for something that starts with a W, it could take a long time. Now, of course, diagnostic is right there. I'm not going to do it yet. I'm going to go back. I don't know why I just did that, but second catalog. Another way to do it is to recognize that the letter D is in green, and your calculator actually has A, B, C, D all the way up to I think Z and beyond. And so if you're in the catalog, you can actually move straight to the D's by hitting the button that has the D above it, which is this X1 button, and it'll take you straight to the D's. and you can go from there. And what you want to do is turn the diagnostic on. Diagnostic off if you don't want it, but right now we want to turn the diagnostic on, and in order to do that we hit enter, and you see that now diagnostic will be turned on. And of course you hit enter to make it happen. Now again, you go to your linear regression, which means we go to stat, calculate, linear regression, which is in 4. That's where you do the linear regression we just did, but you'll notice now that when we do that, that your R is right there, 0.9416, and notice how close that is to 1, and we also notice how close those dots were, which means that it is very, very close to where it needs to be. Alright, so looking at all that, once you turn your catalog on, you no longer have to do both of those. You just would pull up your linear regression. It would have A, B, and R. We don't use R squared right now. But like I said, A, B, and R are really the 3 things that you have to be able to find today if you're going to be successful on a computer. So again, hope you took notes on that as we look through some of this stuff together, about 2 questions, maybe 3. Actually, I think it's just 2. It says students measured the diameters and circumferences of tops variety of cylinders below the data they collected. Estimate the diameter of a cylinder with a circumference of 22. The only way we can estimate the diameter is if we know what the trend line is. And so in order to get the trend line, we have to actually put this information into a calculator, or into the calculator here. So we have to clean out these lists. The way you clean out the list, remember, is you just hit delete at the top row, and I'm pretty sure there's a faster way, but I have not researched nor found it just yet. So this is the fastest way, is just to kind of delete those out. So we go 3, 3, 5, 6, 8, 8, 9.5, 10, 10, 12. And there's that part. On the other side we go 9.3, 9.5, 16, 18.8, 25, 25.6, 29.5, 31.5, 30.9, and 39.5, which should be the last one, and it is. And so again, in order to estimate this, we need to first off get a trend line. The way we get a trend line is by getting the linear regression. So we do stat, calculate, linear regression, and it gives us A and B. So our formula for this, I hope you're doing that with me, and so you can see the numbers, is y equals 3.21x minus 0.38. Based off of these numbers again, 3.21 because I rounded it there. B is negative 3.75 or 0.375, so we round it to 0.38, and you want it for a circumference of 22 centimeters. And again, what you do here is you take the 22 and you plug it in, and then you just type it into your calculator, 3.21 times 22 minus, and you can actually take it from there, 0.38, to get your answer of 70.24. And so your computer assignment today is actually going to be asking you to get that done. But again, you have to remember that if you are estimating, you are using the trend line, which is that equation there, to plug that information in to find out what you're looking for. Alright. If we were going to graph that, let's just do that real fast. Graph. We need our window to be plotted right. Lowest x is 3, so we'll start at 0. Highest x is 12, so we'll go to 15. Again, don't touch the scale there. The lowest y is at 9, so I'm assuming we can probably still start at 0 because it's not too far away from it. And I'll just go to 50. And then when I graph that, you can see this. And then again, if you want your trend line, you simply go to y equals. You type in the equation that we have here, 3.21x minus 0.38. And that should send the line, as we saw, that goes pretty much through the center of all that information. So that is really what we've learned today. The linear regression should be pretty close to positive. First off, it should be positive, and it should be pretty close to 1. Let's look back at that part there. Again, your linear regression here was 0.998, which is almost straight, which tells you that this graph makes sense because those dots are pretty much on that line, very close. Number 21, last one we do. Use a graphing calculator to find the equation of a line or best fit for the data below. Let x equals 8 represent 1998. So I guess this will be 8, 9, 10, 11, 12, 13, 14, and so on. And so that's what they gave us as a point there to use. Now only use this if they tell you to, because other than that I believe you'll just type in the times as they are. Other than that, we got to again erase our stat plot, so we delete all these numbers. Again, there has to be a faster way to do this, but I'll find that at some point. And then we will just go ahead and plug these things in. Again, 8 for 1998 means I'll go from 8 all the way up to, I think, 8, 9, 10, 11, 12, 13, 14, 8 to 17. So 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. And then you go over and you enter the information 152.4, 184.5, 196.3, 210.3, 225.8, 240.9, 249.5 for 2014, yep, 229.5 here, 241.6, and 267.9, which is our whole chart there, as we see. And again, the first thing they want is equation of the line of best fit. Again, the equation of the line comes from the y equals mx plus b, so we have to do our calculation of the linear regression, which gives me this and gives me a and b. First off, your line of best fit is going to be y equals 10.53 x plus 88.21. Again, that comes from these two numbers here, 10.53 and 88.21. They want the slope of the line of best fit. The slope, of course, is always going to be there, so your slope is 10.53. And what that tells us is, again, rate of change means it's this change based off of that, so pretty much every year it's going to increase by about 10.53. What is the y-intercept of the line of best fit, which is 88.21? What does it represent in terms of the computer and video games sold? If you remember, the y-intercept occurs when x equals 0. So in other words, when x equals 0, based off of this, it would be at 1990. And so this represents the number of video games sold, or number of millions of video games sold in 1990, based off of this situation. These two things are not always important. It is kind of important to know what the rate of change is, but again, in terms of overall information, you don't usually have to deal with what the y-intercept is. Other than that, make sure at this point that you know how to do the following things. You should know how to calculate the linear regression, which is just simply going to the stat button, going to calculate linear regression. You should be able to access the catalog to turn diagnostics on or off. So we can do that. Go to second 0, hit the D button, and then again you have your diagnostics on or off. You should be able to use diagnostics to find the value of R, and you should be able to sketch a trend line over a scatter plot like we've done before by using the y equals button. So other than that, before you move on to also your Math XL assignments today are C and D, because we're still in the same section of 5.7. So again, this represents your A, this represents your B. This is what needs to be done on paper if you want credit, but this is just your homework. But before you go on to Math XL, work out the following problem for your bell ringer activity. The question is, what is the equation of the trend line? Write that on a piece of paper. What is the correlation coefficient? And estimate the value at x equals 12. Also, sketch the trend line in your calculator and show it to me for part of your bell ringer credit. So I need to see the equation. I need to see what R is. I need you to tell me what the value is at x equals 12. And I also need to see your calculator with the trend line sketched in it also for credit. So go ahead and do that now, and good luck today. Test at the end of the week, so make sure you're studying.